Now let's look at meter bridge today. Let's do a briefing on meter bridge. When you talk about meter bridge is an experiment that is used to determine the resistance of unknown resistor. Is an experiment conducted to determine what the resistance of an unknown resistor. So here, let me explain the outline of this diagram. We have two resistors here, R1 and R2, and they are being connected to a metallic strip. See the metallic strip here, and another center metallic strip, and another metallic strip here. So this middle metallic strip is connected what we call a galvanometer. A galvanometer. Basically, a galvanometer is what we call a moving coil. It uses the principle of electromagnetic induction to indicate the flow of current. So this galvanometer here, its beauty is when there is current, when current flows through it, it's going to deflect, either deflect to the left or deflect to the right. So galvanometer is used to indicate the flow of current. So whether it deflects to the left or right, it all depends on the direction of the flow of the current. So this galvanometer that is in this center is used to know when there is a current flowing through the system. But however, in this meter bridge experiment, how we apply this galvanometer here is to make sure that there is no deflection in it. There's no deflection. No deflection. We call it null deflection, meaning no deflection. So that's the part we want this galvanometer to play here. So, and here we have a 1 meter resistance wire here. 1 meter resistance wire here. And here is the calibration or the scale. The scale for the 1 meter resistance wire. This scale here measures from 0 to 100 cm, or you say from 0 to 1 meter. 1 meter is basically what? 100 cm or 100 centimeter. So this galvanometer here, the jockey, which is the pointer from the galvanometer, is being placed on the resistance wire, the 1 meter resistance wire, and we keep tracing the part on that 1 meter wire until there is no deflection on the galvanometer. So that is the essence of the experiment. That is how the experiment is conducted. Once you take your jockey, you place it on the resistance wire, you keep pressing it until there is no deflection. That's the deflection on the pointer of the galvanometer points at 0, meaning there's no current flowing. So at that point, when there is no current flowing or when there is no deflection, it now means the resistance on the left part, the ratio of the resistance on the left part of the system or the meter bridge is equal to the ratio of the resistance on the right part of the system. So now, at that particular point where you find the galvanometer to be balanced, from the 0 point mark, 0 is from the left hand side, from the 0 point mark to the point where it is balanced, you label it L1. Then from that point where it is balanced to the extreme right, you label it what? 100 minus L1. You know, this is a 100 meter or 100 cm scale. So if from here to here is L1, the remaining one will be what? 100 minus that L1. Minus that L1. So setting up this thing, if you were to write WAEC or GCE, this apparatus will be made available to you by the school or the exam body, depending on the country you are. So once this apparatus is set, you'll be given two resistors, one unknown and one known. And then you set up this, your meter bridge. Here, what you have here is your battery, or you say cell. Is your battery, or you call it what? Cell. And this point here is your switch. That switch, that's to turn on the system or you turn it off. So now, once you've set up and put your resistors, the unknown and the known, you now trace the galvanometer and trace where there is no deflection or where it doesn't deflect. Because normally once you switch it on and current start flowing, it will be indicated on the galvanometer. So you now trace on this resistant wire or resistance conductor and see where the galvanometer refuses to deflect. So that point where it refuses to deflect is the balance point. So you take the reading, However, if you are doing theory, if you are answering questions with respect to meter bridge in a theory format, there is no actual meter bridge there for you to trace the unit, so you have to use some calculation. So once you're able to trace, or once you know where the galvanometer is balanced, that there's no deflection, this holds true. The ratio of the resistance on this side, which is what? Okay, which is R1. Remember that the resistance that a metallic conductor has is resistance, and that resistance is directly proportional to what? Length. Are we aware of that? That resistance is directly proportional to length. So R1 here is directly proportional to what? This one, L1. And then R2 is also directly proportional to what? The length of this conductor from here to here. That is proportional to 100 minus L1. 100 minus L1. So in that system, when you finish up that will be R1 over R2 will be equal to what? L1 over 100 minus L2. So this relation here, or should I say this formula here, this relation here is all you need to know to calculate the resistance of a non-resistor in a meter bridge. There are videos that we have a lot of examples of WAEC JAMB questions on meter bridge. So for a meter bridge, the relation at no deflection, what holds true is that R1 over R2 is equals to what? L1 over 100 minus L1. Did I write L2 there? Sorry. 100 minus L1. 100 minus L1. So basically, this is what a meter bridge experiment is about, or a meter bridge theory question is about. Normally, one of these resistance will be unknown, and then you know the deflection. We are going to solve a lot of examples on this, but this is what meter bridge is about. So we use it to determine the resistance of unknown resistor. And some of you may wonder, is this not an old thing? Do we need this kind of system to even measure the resistance of a resistor when we have digital multimeters and the rest of it? Now, yes, it's true that we have digital multimeters that you can use to measure resistance without going through this apparatus system. But here, at the level of engineering, that digital multimeter you are using, have you ever wondered how it was designed? Have you wondered the principles in which it operates? Now, if you don't understand a meter bridge, Watson bridge, and all those instrumentation, in electrical engineering, you will not be able to design a multimeter. Yes, you didn't be able to design a digital multimeter because a digital multimeter basically uses the principle from a meter bridge and all these other theories. The only difference is that it has been digitalized and the size has been made little. So for you, so the knowledge of this is still as important as it is for engineering, because every invention you may think of, no matter how complex it is, has its base where it originated from. All right. So thank you.